Okay, let's take a look at some of the homework problems for tonight. Let's start with letter G. This one looks a little bit intimidating, but if we kind of take a step back, it's really not that bad at all, okay? So today in class, I exposed you to an indeterminate form, 0 over 0, which tells you that you have factors in the numerator and denominator that cancel. These are not quadratic, so there's nothing to factor here, so we're going to have to think about this in a different way. So if I was to immediately plug in 0, I'd end up with 1 over 0 plus 1 over 0 plus 3 is just a third over 0. So I know that we used to say that 1 over 0 is undefined in Algebra 2 and Pre-Calc, but now that we're taking limits, we know that this is going to end up being infinity. Okay, so this goes to infinity, so infinity plus a third is just infinity, and then infinity over 0 is another indeterminate form. Okay, it just means that we have to take a second look at the limit, and it's not solvable by substitution. Okay, the other thing that we should know about this one is that this is a transformation of the parent function 1 over x, which looks a little bit like this. So we know that around 0, it's going to be shooting to positive and negative infinity depending on how you're approaching. All right, the actual one is obviously a little more complicated than this, but it's some version of 1 over x. All right, so we have to figure out for this particular limit which direction of infinity this one's going. All right, so all we're going to do is take a look from the left and the right. So we'll take a look at the limit from the left and a look from the right. And then basically we're just going to plug some values in. Okay, so we'll pick a number very close to 0 from the left and from the right. For this one, I'll pick maybe 0.01. We'll make that negative. And then this one will do positive 0.01. All right, just values super close to 0. All right, and then we don't care about actual calculations here. We just care about the signs. We're going to do a sign analysis. So if I was to plug in, let's start with the left-hand side, 1 over negative 0.01 plus 1 over negative 0.01 plus 3 all over negative 0.01. Okay, so all I'm interested in is the signs here. Okay, so if I look at this, this is going to be a negative number. This is actually negative 100 if you were to simplify. So let's do this. So this is negative 100. And then this is almost a third. All right, almost a third. But again, all I care about is the sign, so the top or the numerator is going to remain negative, and then the bottom, of course, is going to stay negative. So overall, this is going to positive infinity when you check from the left. From the right, a very similar idea. We're going to do 1 over 0.01 plus 1 over 0.01 plus 3 all over 0.01. And everything is positive. So this number's positive, this one's positive, and so is the denominator. Okay, so this is going to be shooting to positive infinity as well. So therefore, we're going to say that the limit as x approaches 0 of this function 1 over x plus 1 over x plus 3 all divided by x does not exist because infinity is not a real number. Okay. Very similar in letter J here. So in this one, we're just looking at 5 from the right. And we know that if we were to immediately plug in 5, we'd get 23 at the top over 0. Okay, so this is indicating asymptotic behavior as well. So we're just going to take a look at the limit from the right. So I'm just going to plug in a number super close to 5 from the right. Let's go with maybe 5.1. That's close enough. And when I plug this in, again, I don't care about actual numbers. We're just trying to do the signs. So we'll just plug this in, 5.1, and then minus 5. So at the top, we're going to get some positive number, whatever that is. And at the bottom, 5.1 minus 5 is still positive. So this is going to positive infinity. Therefore, we can say the limit as x approaches 5 from the right of the function 4x plus 3 over x minus 5 is equal to infinity. Okay. And the only other one that might be a little tricky, at least if you first look at it, would be this one. This is letter E. We have a piecewise function, and we're looking at the limit as x goes to 0. So we're going to have to use two different pieces of the function here. So let's take a look at the limit as x approaches from the left and approaches from the right. So if I look from the left, that's going to be values less than 0, so I'm going to use the top piece of this function. So we're going to use e raised to the 2x power. And then I can just immediately plug it in, okay? So before we do that, we just need to remember that e raised to the 0 is equal to 1. E is just a constant value. It's a transcendental irrational number, just like pi. And any number, any constant raised to the 0th power is always going to be 1. So we're just going to plug this in. E raised to the 2 times 0 would give us e to the 0, which is equal to 1. So from the left, the limit is equal to 1. When I approach from the right, that's values greater than 0, so we'll use the bottom piece of this function. So the limit as x goes to 0 from the right, we'll use x times e raised to the x, and then we'll immediately plug it in. We're going to get 0 times e raised to the 0, which is equal to 0 times 1, which is equal to 0. So for this one, we're going to say that the limit as x approaches 0 of the function f of x is equal to not existing. Okay? All right, I'll take some questions in class tomorrow. All right, see you tomorrow.